All right, so just like when we were adding integers, our rules are actually the same for adding rational numbers. And so they're the same rules. So same sign, we know that we have to add absolute value. Sorry, my line wasn't large enough. Of the integers and keep the sign. So just like we were taught last week, we just add the two numbers, we keep the sign. Different signs, we subtract the absolute, we subtract the lesser absolute value from the greater absolute value. So we subtract big minus small is pretty much all we do. And then your answer should use the sign, whether that's positive or negative, of the number with the greater absolute value. So our bigger number should have the same sign as our answer. All right, so example 1. We need to ask ourselves first if they have the same denominator. So just like we did up here, we're going to see, well, do they have the same denominator or different denominator? For example 1, they have the same denominator. And so we don't have to find a common denominator, so we can just go straight into our addition rules. So ask ourselves, are they the same or different? If so they're the same sign. No, they're not. They are different signs. This one is negative, and that one is positive. So that means that we need to subtract. So we're going to do 3 minus 1. And we leave it all over our denominator of 5. Just like up here, and they had the same denominators, we added the top, but we kept the bottom the same. But down here, our rule says we actually subtract. So we subtract the top and we keep the bottom the same. So 3 minus 1 is 2, and I leave that over 5. And then it says keep the sign of our larger number. Well, my larger number was positive, so my answer is positive. That was supposed to be boxed in. All right, example 2. These denominators are not the same. So before I can start my using my rules, my addition rules for rational numbers, I need to change the denominators to be the same. So the easiest thing to do here is see, can I turn this 3 into a 6? And how do I do that? Well, I multiply 3 times 2. And if I need to multiply my bottom, my denominator by 2, I also need to multiply my top number by 2. So now 3 times 2 is 6. 8 times 2 is 16. And that was already negative, so don't forget to bring that little guy down. Then we're adding that to 5 over 6. All right, so now that we have the same denominators, I'm going to ask myself, are the signs the same or different? So I am going to subtract, and I'm going to keep the sign of my larger number. So let's subtract them. So I have 16 minus 5, and then I'm going to keep it all over denominator of 6. So 16 minus 5 is 11. I'm going to keep that over 6, and my larger number was negative. So my answer is negative. Now, I think Big Ideas will let you keep it as this, but I want you to simplify it or at least try. So we say, how many times does 6 go into 11? 6 goes into 11 one time, and that gives us 6. And then, so how far is 6 from 11? It is 5 away. Add a 6. And so my answer is also equal to negative 1 and 5/6. You can also do 11 divided by 6. 6 goes into that one time. That gives me 6. subtract, and I get 5, which is my remainder, and that remainder goes on the top of my fraction. Okay, example 3. So before we can start, we have to turn these into improper. So to make this a fraction, I'm going to just put it over 1 because every number is actually over 1. So now I have 4 over 1 plus, and now I need to turn this into a mixed number or into an improper fraction. So right now I have a mixed number and I need to flip it. So 5 times 1, and then we add it to the 1 on top. So 5 times 1 is 5, plus 1 is 6, and my number was originally negative. So I have negative 6 over 5. Now my denominators are different, so I need to make these the same. So how do I turn a 1 into a 5? I multiply it by 5, but I have to do it on top and bottom. Whatever you do to the bottom, you have to do to the top. So 1 times 5 is 5. 4 times 5 is 20 plus negative 6 over 5. These are different signs, which means I subtract. So 20 minus 6 all over 5. We keep it over our denominators. And then 20 minus 6 is 14. Oops. So I have is equal to 14 over 5. My bigger number is positive, so my answer is positive. And then to turn it into a mixed number, we see how many times does 5 go into 14. Goes in there 2 times. 5 times 2 is 10. And 10 is 4 away from 14. And we keep it over 5. So there is my answer. Our last example before you guys get to try is a decimal. So decimals are also rational numbers. And so these decimals, we are going to use the same rules. When we have decimals, we just need to make sure that we line up our decimals. So we can see here that they're the same sign. So I'm going to do the same sign and add them. So I'm going to put them as negative 0.75 plus negative 1.5. Now our decimals have to line up. These have to be equal to each other. Our 7 and our 5s are in the tenths place, and then we have a 5 in the hundredths. So now we have to add a 0 behind the 5 so that way they all match up together. So you always line up your decimals whenever you are adding decimals. So now we just add like normal. 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. My decimal comes down. And then 1 plus 1 is 2. And then both of my numbers were negative, so my answer is also negative. So my answer is negative 2 and 25/100ths. So now you are going to try it's below, and then I have a video in which you'll check your answers with mine.